Okay, so sorry, had to redraw that. It kind of got weird. So this is like where we left things last time, to where you could reduce this whole thing to a very simple circuit. All right, but now let's look at part E. It says, calculate the final charge on the 5 microfarad capacitor. Oh no, but we got rid of those. Why are they asking about it again? Great. Yeah, because they are. Now we're putting this back here, and I'm just going to kind of put it in as kind of a dotted line type thing. I'm not doing it in pink. It's just that here's your 5 microfarad capacitor. Just going to kind of put that back in there like that. That's not going to work. I'll just draw it. 5 microfarad capacitor right there. Now, you've got kind of this different situation going on. First, and this is going to help with the parts E and F, I want to do one thing. I'm going to just redraw this, just again as your simple circuit thing. So this is 20 ohms, and this is 40 ohms. Now, and this is 30 volts. That's a battery. So, according to the loop rule, this one loop if it's a series circuit, this whole voltmeter should read the same. Actually, if this is negative, positive, and vice versa, this one should be negative. 30 volts. Now, current's flowing through both of these. It's not like anything's cut off. So this 30 volts is actually going to have to be divided into voltage drops across this. They're not even. This is not the same amount, 40 and 20. And recall, resistance for the circuit is, let me write that over here. Resistance for the circuit is 60 ohms. All right, well, how much of your resistance resides on this 40? This would be right here, this one. It would be 40 over 60, which you could reduce to 2/3. So you got 2/3 of your resistance right here, and that means this one must be 1/3 of your resistance. Because, you know, 2/3 plus 1/3 equals the whole. Now, if you recall, voltage equals current times resistance. So see how voltage is directly proportional to resistance? So if I have 1/3 of my resistance here, I'm also going to have 1/3 of my voltage going through this resistor. So, clean this up a little bit. That one's 20. It's kind of not a good place to write the 20, or 1/3 of the resistance, because it's 20 ohms. So that means a voltmeter across this one is 2/3 of 30. Well, that would be 20, because, you know, if you divide 30 and 3, it's 10, and 2 of those would be 20. So this is 20 volts right here, and then this one would be 10. So what I'm going to do is I'm going to draw your voltmeter right here across this one. This is 10 volts. You don't have to do all this, please. On an AP test, don't go to this detail. I'm just wanting to show you what it is. And the voltage drop across this 40 is 20 volts. And I got that because I just divided up the resistance, which is directly proportional to your voltage. And then the loop rule, they all have to add back together to 30. So see, 20, I've got one loop here. I'm ignoring this right here in the middle because that's kind of cut off. So with the one loop, I have 20 volts plus 10 volts. And then we have that equals 30, and then you have 30 here, which presumably is the negative, and so it would all total to 0. Or basically, loop rule, battery equals the total of the voltage drops. That's going to help you for both the next parts. So let's get back to this one. Again, part E said, calculate the final charge on the 5 microfarad capacitor. Well, you're going to have your caps are quite overvalued. So therefore, Q equals CV, and that is going to give you 5 microfarads times the voltage drop. Oh, wait. Now, what are you going to use there? Use a different color real quick. Here's the deal. You can look at this, now since I put this thing kind of back in here, as 2 loops. You got your loop around these 2, and you have your loop right here around this. I'm not going to do a third loop. We're just going to look at that. So that means the sum of the voltage drop of these two components needs to be 30. And the voltage drop across this needs to be the same as the voltage drop across that. Either way you want to look at it, that's fine. I'll put my voltmeter in here and let's look at what it is. Well, this is 20, so that has to be 20. Easy enough. Let's double check. These two added together, this voltmeter and this voltmeter, have to equal 30. 20 plus 10 is 30. So you are good on both counts. You could have also looked at this as like 30 minus 10 is 20. However, you feel good about that. So I'm going to put my 20 volts in here. And 5 times 20, I hope, is 100. And that's microfarads times volts, which, let's not like break all that down. That is charge, Demas and Gerardo, coulombs. But then you have your micro, 10 to the negative 6, and there you are. Part E.